So now we're going to look about the graphical method of analysis and dynamics of rigid bodies. So graphical method of analysis are usually used when there are varying acceleration, velocity, and displacement with time. So this is applicable in problems where there are two or more governing equation, or there are two or more changes in acceleration, velocity, and displacement. So graphical method of analysis involves the the ST graph. So this is the ST graph. As you can see, T is our x-axis and S is our y-axis. So let's take for example this graph. This graph is a graph of a parabola. Let's say this is S. This is your S rather. So this is S is equals to T square. Let's say this graph is S is equals to T squared. So if your motion starts from rest and its initial velocity is 0, or let's say it starts from rest or it starts from 0, and then we can measure its motion, or we can graph its motion by substituting values in terms of time. So let's say time here is 5 seconds. So if your displacement says that t squared, well, you'll just substitute the value of 5 here. So 5 squared is equal to 25. So at 5 seconds, your displacement is 25 meters. Same goes, for example, we have here 2.5. For a time of 2.5, your displacement would be 6.25. So that is how you construct your graph. And then we have the VT graph here. So the VT graph, we have T for the x-axis and V for the y-axis. So this graph is the continuation of your governing, or of your equation S is equals to T squared. So how do we derive a equation for our VT graph from our ST equation, or from our ST graph? So since we have the formula V is equals to ds over dt, we can create a equation of V. So we have d over dt times t squared. So the derivative of t squared is 2t. Therefore, this equation here equals to V is equals to 2t. So let's say you start from rest, or you just substitute the value of time. 0 times 2 is just 0, so it's given that your initial velocity is 0, as well as here in your displacement. If you substitute the value of 0 at 0 time, your displacement is 0. So let's say at 5 seconds here, your velocity will be 10 meter per second. So also at time 2.5, so at time 2.5 seconds, your velocity is 5 meter per second squared. So that is how you create your VT graph. For the AT graph, we'll be able to get our equation for our AT graph using the formula A is equals to dV over dt. We have d over dt multiplied by 2t. The derivative of 2t is equals to 2. Therefore, our acceleration here is 2. A horizontal line indicates that it has a constant acceleration. So always remember that if your velocity here is in constant rates or just a diagonal line, and your equation has the degree of your equation is only 1, which means your acceleration will be constant. So at any time given, your acceleration is 2. Oh, it's 5 seconds rather. 5 seconds. Which means at 2.5 seconds, your acceleration is also 2. So the SD graph, VT graph, and the AT graph can vary depending on the equation given. For example, or given S is equal to T cube, your graph will be different from this. So let's take, for example, you are given a governing equation that is an acceleration. Let's say A let's say you are given a governing equation of A is equals to 3t. So graphing this, have A here, T. Since it has only a 1 degree, or its highest degree is just 1, we can say that this is just a diagonal line, just like our VT graph here, just like that. So to further explain it, you can use your table to graph. We have 3x starting from 0 until, let's say, 5 seconds. We have for 0, 3, 6, 9, 12, and 15. There are constant rates of 3 in every second. Therefore, your graph should be this. So at 5 seconds, your acceleration is 15 meter per second squared. So how do we derive an equation from your AT graph to your VT graph? So we have the formula here. A is equals to dv over dt. We'll just rearrange it. We'll have dv is equals to a dt. So instead of derivating or differentiating our equation, we'll be integrating. We have integration of dv is equals to 3t dt. Integration. So we have v is equals to, so in here we have our limits. So let's say our particle starts from rest. We have our at t0, our velocity is also 0, v. Starts at rest at the origin. We have 3t, the integration of 3t is equals to 3 halves t squared. So that is our velocity equation. V is equals to 3 halves t squared. So how do we graph that? So since its highest degree is 2, its graph should be a parabola. We have VT. You can use also your calculator to calculate that, or to create a number for your graph. 0 to 5. You have 0, 1.5, 6, 13, 24. It's understandable that your graph should be a parabola. And then, at 5 seconds, will have a 37.5 meteor per second velocity. So again, in order for us to get the SD graph here,